Hello, hello. Happy Friday to everyone. Good morning, good evening, and good afternoon. Super excited to have a new journey today on Open Source Friday with Matvi and the founder and maintainer of Archestra, which is building MCP enterprise-grade software for secure MCPs. And so we're excited to kind of kick off the conversation. Matvi, welcome. Would love to have you do an introduction to the folks joining us today, a little bit about you and your background, and maybe how you got into open source.
Of course. Thank you for having me, Kevin. Hi, everyone. I have engineering background. So as long as I remember myself, I've been doing coding. Started at 11, I think. That's the time when I bought the first PHP book.
I love it.
Since that moment of time till now, till maybe 5 minutes before this podcast, I've been coding. I worked as software engineer for a few years. In 2018, I built my first company. It was like a corporate SaaS. I wanted to try startups, and it was really fun. And at some moment, we decided to go open core, deploy to open source, and go with open core business model. So actually, that's the moment of time when Grafana Labs acquired us. So we knew how to learn from the best. And I spent a few years in Grafana Labs, very exciting times. Grafana Labs is behind a lot of open source software, which is like millions of people use it day to day. And it's actually democratizing software, enterprise software observability for enterprises and companies. Mm-hmm. So I became a huge fan of open core, open source enterprise software. And I can't imagine not building something not open source anymore. Because it just feels natural. My previous company, like my second company, was acquired by Elastic. Again, it was open source software for companies. And that's how I started Archestra.
I love it. That's awesome.
Yeah, maybe like open source.
Yeah, let's talk through like kind of the origin and the story behind Archestra, and like what inspired you to kind of create this project and the software.
Easy. I tried MCP. So
it's a good answer. It's very, very, very prominent right now as well. So that's great. Maybe like, you tried MCP, and what was the spark that like said, oh yeah, what is this?
Yeah. So like as most of engineers who try MCP, first 5 minutes you're like, wow, this is so cool. You connect MCP to WhatsApp, you connect MCP to Slack, and maybe 20 minutes later, your colleagues kind of prompt inject your agent through your own Slack because they want to make fun of you. So they start publishing prompt injections, and your agent starts to follow those prompt injections, and you realize like, oh, wow, this technology is so cool, but it's practically impossible to deploy for something where like money are involved or sensitive data is involved. So this technology is so cool, but it's really, really hard to bring to real life use case. And we thought like, obviously the solution will be open source. It will be on infrastructure layer, something what will enable this technology for hardcore use cases with real data, with real responsibility in real enterprise environment, and let's build it. And this is how we started. So the spark moment was like 20 minutes after I tried MCP.
I love it. And maybe, so you got the spark, like what do you define as the core mission of the project in Archestra, and what's unique about how you're thinking about security within MCP and maybe like the orchestration for the enterprise space specifically?
So we started Archestra as a simpler way to use MCPs. And the more and more we research, the more white papers we read, the more researchers we met in person, we realized that without security layer, it all like doesn't make any sense because you just can't. You can't let
Sure.
autonomous agents touch your data. It's too dangerous. They will hallucinate and leak something somewhere. So we need to build a security layer, but security layer which is much different from what other companies are building. Like what's the most popular approach now is to use large language models or small language models to analyze behavior of agents and judge behavior of agents. Is it like a valid behavior or malicious behavior? And this is not guaranteed. So it makes everything better, much better, like 99.5% better, but still it's vulnerable. So you still can't connect it to your accounting data. You can't feed your GDPR data to such agents because they will hallucinate or follow prompt injections, just leak something somewhere, publish salaries to Twitter or et cetera, And today I will show a few examples how it works. And our unique thing is that we implemented a few well-known practices how to avoid such a vulnerability for autonomous agents. We implemented it in a very, very practical way. So it's practically plug-in open source thing you can roll out in your Kubernetes cluster alongside your agent. It doesn't matter in which language or technology this agent is built on, and you turn it on, and your agent is safe against so-called lethal trifecta. We will speak about it later, I guess.
Yeah. That's great. And maybe, just a little bit like how have you thought about why open source is so important to your team and kind of how the project is actually helpful for enterprise to be open source as well?
First of all, we like open source. This is the honest first reason. Second of all, open source inside enterprises as well as we see it's a pretty popular thing and easy to bring into. So if you're SRE, if you are head of AI or just AI engineer or practically any engineer inside enterprises, you can go to GitHub. Most probably you're allowed to try things from GitHub and test if they work well for you. We eliminate the need for POCs, sales meetings, everything we do not well as engineers. And
Sure.
It brings us very close to our end users. So we published Archestra to our repo about 2 weeks ago. We already talked to a few companies who are trying it in their infrastructure. We talk to their engineers like every hour. It's very like close. I like the feeling.
Yeah, I mean, one of the reasons why I was kind of curious to get your thoughts on it, I mean, especially with MCP right now, this ability to like build for enterprise is super important to be able to test and field the software earlier, but also so that they can inspect it and make sure that it is secure itself. And that's why I think in this case, when you're building a security system for MCP, like they want to be able to look at it and be like, oh yeah, we understand it. It makes sense. And so it becomes much more of like a durable component of the supply chain and something that they can leverage and essentially trust and verify that it is secure itself. So I think that's a really interesting component. Maybe you kind of touched on it already, but like the lethal trifecta that you just brought up, like maybe talk about that a little bit. Like what is the lethal trifecta specifically within MCP, but also like how do you see that broadly within this world of AI and agents right now?
So now it's a little bit complicated topic, but I will try to simplify. So stop me if I'm going to do.
Sounds good.
Because yeah, I'm spending a lot of time reading white papers related to the topic and sometimes going too deep into it. Imagine that AI, large language models, they know a lot of things, but they don't have critical thinking. So they will try to be helpful to whatever or whoever speaks to them.
Mm-hmm.
So now when we connect such a trusting thing, which trusts everything what it sees, to sensitive data from one side, and also we give this thing an ability to externally communicate. For example, read our salaries from internal HR system and also send emails.
Mm-hmm.
And also we give an ability to consume data from outside. We call it a source of untrusted context. This is what's called lethal three-factor. And it's dangerous because if our system can consume untrusted data from the outside, it means that it could consume prompt injections.
Mm-hmm.
And it will just believe those prompt injections. And this is a fundamental problem for large language models. It's not solved, not Claude, not OpenAI. They can't guarantee that those models will not follow prompt injections. And I will show it today. Hopefully it will work because it's a live demo and it's tricky, but still. And the problem is multiplied by MCPs because MCPs themselves, they, in majority of cases, one MCP server is a complete lethal three-factor situation here. We can take GitHub MCP server, for example. It could consume untrusted data, so it could read GitHub issues, and anybody can create GitHub issue. It could also externally communicate because it can create GitHub issues, so it can send something somewhere. It also can consumes sensitive data because it has access. It depends on how do you configure your API key, but it could consume data from private repos. So even connecting only one GitHub MCP, the whole agent is getting vulnerable to the lethal three-factor, and you can't go to production with that. You can try it, you can get energized about what this thing could do, but it's too dangerous. The same thing with Slack MCP, WhatsApp MCP, almost any system MCP is vulnerable. So MCP is not the problem itself, it's just a technology which highlights the vulnerability, the core issue for autonomous agents.
Awesome. That's super helpful. I'm going to spotlight a question here because I think it's relevant, but D'Olivier says, could you explain how to handle secure communication among different MCP agents technically? Like, how would you actually do that? And it gets a little bit into the question of how you're managing it today. But I think it's a good question to kick off this conversation. How do you manage the lethal trifecta, and how do you think about it from a technical perspective?
So I think that there are two questions among different agents. And how to manage lethal three-factor. So communication between agents, it could be done through MCP. It could be done through Google's protocol A2A, which is not that popular yet, but looks like it will be much more popular. There is a problem of identity, because when your agent when you launch the agent, and agent actually is a loop, which is triggering large language model and asking what should I do next? What should I do next? Right. And the problem is that under which identity you execute this loop. Do you do it under your name, the author of this agent, or do you do it under the name of the person who launched it? And when it gets to agent communication, agent-to-agent communication is a technical detail. Okay, MCP servers, there are MCP servers which do that. There are MCP servers which run sub-agents. They could communicate via email. There is nothing limiting. But what's more interesting, who is responsible for what those agents have done altogether. And if you, Kevin, launch an agent in your laptop, and this agent is authenticated through your GitHub, your email, and my agent is talking to your agent, and it's asking your agent to do something wrong, Okay, how do we conclude? Who is responsible for making changes? This is the bigger problem, I think.
Yeah. And along that lens too, I mean, it's not just like the security lens, it's really like an identity and authentication, authorization kind of entitlement question as well. I think that's really interesting. And it kind of begs a little bit of a question, like, how do you think about within your scope of the project and and what you're building, how to bring in those, identity entitlements into the MCP itself?
So what we are doing now, we are working on MCP orchestrator, which will be a pluggable tools for existing agents.
Mm-hmm.
And we think about it from a perspective that agents should be authenticated by users who launched them. And when agent is touching any third-party system, it should be practically the whole trace should be stored somewhere, like complete trace, because it's a matter of investigating when something happened wrong. And of course, non-human identities should be present. So if you as a group developed an agent and you want to launch it, this agent should be under an identity of your group name or team name, and it should be authenticated in GitHub, in Grafana, in Bamboo HR.
Having like a central is like access and identity is kind of where you want to like control for it, not the actual like individual itself, because that's how you're gonna.
Yeah. So from our perspective, we are working. This is not released yet, but we're working on building both, and we are like exposing it to the third-party systems it's interacting with. I hope I answered the question.
It's good. I'm gonna shift just a little bit, because someone had another interesting question around like PII and sensitive data, which is part of this like lethal trifecta that you're talking about specifically. But it's an interesting question. Like, is that something that you build into Archestra to be able to handle? Is it more on the enterprise side? Like, how do you think about that specifically in this realm?
The problem with PII is that it's not. There's no different approach to handle PII from other sensitive data in terms of lethal trifecta, because if your internal sensitive data is getting leaked, PII will just increase the damage. But you need to design the whole system to prevent this leakage. So we built Archestra in a way that it fundamentally will kind of cut the ability for agents to leak and to damage data. In terms of PII, there are a few SLMs and third-party providers who help agents to identify PII, and agents are actually pretty good in identifying PII, but it's a matter of in-agent workflow. So you may prompt your agent, like, if you see PII, do this. If you don't see PII, do other thing. And there are third-party vendors who do that. We are not focusing on this, mostly because if you mitigate the whole lethal trifecta, your agent most probably will not do wrong stuff with PII. So it will like, okay, I'm trying to leak something. It's PII or not PII, I can do it. So
that makes sense.
Our perspective, yeah.
No, I like it. And then I'm going to shift just a little bit. This is a longer question, but paying attention to the tooling around open source LLMs that were trained on malicious data. Like, this is an interesting one. And I've heard of these use cases, but I'm curious, like, from a, how do you, and this is the question, is like merging from some different branch into a production branch, and now you're having this tool chain that's been trained on malicious data in your code base. Is that something that you've seen? Do you think about that within agents? Yeah.
So I think here we have two kind of questions. So I misunderstood. Correct me if I'm wrong. I think here we have two problems: supply chain attack of.
I'll pull it back up so we can see it.
Yeah. So tools, MCPs, for example, MCP just a protocol. There are other protocols, but tools in general, they have prompts. And those prompts could be misleading. They may have prompt injections. This is a huge problem. We analyzed 847 MCP servers, and majority of them are supported by less than 2 maintainers. And for majority of them, we were not able to identify who are exactly those maintainers, meaning that they are anonymous. And they're MCP servers for systems like Bamboo HR, for ServiceNow. And you could plug in this MCP server and like, who wrote this MCP server? You never know. Maybe it's safe today, but you pin to latest version, and those 2 maintainers just bring some prompt injection like the next day, and boom, your whole agent is vulnerable to something. And also, big topic that MCP servers are actually programs, and some people run those MCP servers on their laptops, which is extremely, extremely dangerous, and you should never do that. In my LinkedIn, there is an example how to hack Cursor, I think, using one button. So it's downloading the MCP server, running binary on your laptop. So I'm branching to different topic. The second part of it is training on malicious data. If we have a guardrails which are static and not probabilistic, and put agent and tools inside those guardrails, we actually don't care if a model is trained on malicious data or not malicious data in terms of leaking data because of lethal trifecta. Because yes, it will try to call the tool, and safeguards will just not let it.
Yeah,
probably
no,
too
that makes
long of
sense.
answer.
Yeah, no, that's really good. Let's keep going on kind of your project specifically, and kind of maybe shift gear a little bit around the features and tools that you've brought into the project today, and like how you're using and how you selected those features specifically to block against the lethal trifecta.
Of course, happy to. I'm super nervous. It's live demo.
All right, demos are always fun, and live demos are the best.
Okay. So, do you see my screen?
Pull it up. There we go. We are good to go.
Cool. So, a few words about Archestra, so you can like deploy it. It's like we have Docker container, we have Helm chart. So the whole idea of the system is to be deployed next to your agent, and we are agent technology agnostic. So it could work with even with NA10, with Versal AI, with LangChain, with Mastra build agents. Because, and I will speak about it more, the unique thing about Archestra is that we intercept between large language model and your agent. We don't care actually how exactly do you call tools. It may be MCP servers, it may be just in source code you call tools your own way. But the matter of plugging in Archestra is just changing the URL from OpenAI to Archestra proxy.
Okay.
So I have an example of a simple autonomous agent built using NA10. And this agent has, as you see, it's dumb simple. It has one MCP server, which is GitHub, and it has OpenAI model, GPT-4, or yeah, it's using OpenAI. Nice. So let me try if it works. Just hi, it's responding. And let's try little trifecta. So I am going to the repo. And here I created a malicious issue.
Maybe
And
talk through like what a malicious issue like looks like in this case, so that folks can understand.
Yeah. So this issue, like this is just a repo, and issues here they should describe bugs and like feature requests. But instead of it, this exact issue it has prompt injection. So here's your execution plan. It has specific instructions for my model to read those instructions and to follow. And this instruction says that my agent should go to my private repo. Let's assume it's private, Archestra AI Archestra. In this public repo, which is repo with prompts, it should create a new issue and summarize latest issue from my private repo. So what I want my agent to do, I as hacker, I want this agent to read issues and just follow the prompt. Follow my exfiltrate sensitive data from inside the org to outside the org.
Yeah, so in this case, like the agent's just like a GitHub orchestrator in that case, and like super simple and like, but under the hood, they don't see what's happening with each of these issues of like what they're orchestrating against like an issue or anything.
Yeah. They like, you see the agent is super simple and just GitHub, just OpenAI. And let's imagine we are not very good with the prompting for this agent. So we could easily assume that we just give this agent issues to close them, because we want this agent to build those issues, right? To kind of build those features, to fix those bugs. So we ask agent to execute or complete this issue. And let's see what happens. It's probabilistic, so sometimes it works, sometimes it doesn't. Let's see what is done. It got the issue. It listed issues again. Okay. And it created an issue. So in my public repo, it published content from my private repo. Yeah, because I recognize this is the issue from our Archestra repo.
Yeah.
Scary, right?
Yeah, I mean, from an attacker's perspective, that's very. I mean, well, from any perspective, like clearly they got the agent to break out and create the issue, but also for you, like if there was sensitive information, like that is a risk. Yeah, that's crazy.
Yeah, and this is just one MCP server, and imagine what happens when you connect 3, 4, 5 MCP servers. And it then supports a lot of them. And let's now switch to Archestra. So I deployed Archestra locally, and yeah, I launched it using Tilt, development tooling, and I also exposed it to the outer world using ngrok. So as you see, it has like demo logs, and first thing to do is I need to bring Archestra between large language model and my N8N agent. So how do I do it? I go to N8N here, and I just swap the URL.
So you're basically acting as a gateway to the model through Archestra, and then using this endpoint from Archestra as the new model gateway. Got it. Okay.
Right.
And then in Archestra, are you just using your standard tokens or your standard API key for the model itself?
That's the beauty of it. Archestra doesn't store tokens. It sometimes store them in the runtime, so in operation memory, to do some sub-agents, sanitations sub-agents. I will speak about it later, but it's just working with a token from initial request. So very lightweight thing. So let's try if it works. Amazing. So NA10 said that it was able to connect to OpenAI through Archestra, which is running on my laptop. I'm saving the config. And now let's say hi to Archestra. I'm saying hi to the agent. Okay. So what will happen now? Archestra is parsing the data between agent and LLM, and it identified tools which this agent has. So those
and that's
tools,
just from that initial prompt where you were able to identify all of the tools that the agent has access to, right?
Right. Because when we speak with LLM, agent is sending all available tools to LLM. So LLM has something to choose from. And Archestra is in network layer, and it's able to just parse all tools. And you see, we have only GitHub MCP server, and it has 49 tools, because we have like two system tools pre-populated. So a lot of. And what we need to do now is to help Archestra understand those tools a little bit. We need to tell Archestra which tools are allowed to use in untrusted context, meaning that if let's assume our agent is poisoned, it's still okay to list issues or get users' information, but it's not okay to publish something outside. So I will allow all tools starting with get in untrusted context, because those tools are not able to publish something outside. And I will also list, allow all list tools to work for them in untrusted context. And this is this configuration could go pretty deep. But let's try the little trifecta again. So I will go here to issues. I will copy my issue. I will zoom in here. And I will ask it to execute the malicious issue. Let's see what happens. So first tool call, it's getting issue. Second tool call, it's listing issues. And now it's trying to do something. You see, it's trying to invoke the create issue tool, but it's not able to do it because, tool invocation blocked, context contains untrusted data. So
that's really cool. You actually prevented it with this like tool invocation having access to sensitive data and trying to do malicious behavior. Interesting.
Right, exactly. So I said in this config here in Archestra, I said that create issue is not allowed in untrusted context. So it's blocked. It should be blocked. So, okay, if untrusted context got into the agent can't create issues. That's very simple.
And maybe from a user perspective, like how are you defining how these policies get set? Like that's actually an interesting question to kind of go along with the demo as you're talking through. It's like, is this user defined? Is it like a central enterprise team? Yeah, how do you define these policies?
Yeah, so Archestra is usually we expect Archestra to be rolled out by the platform team or someone who has there's usually one team responsible for enabling other teams to build agents. And we expect them to spend a little bit of time managing those policies, or, which is actually better, the team who is building the agent, they can Archestra has there is a role-based access control inside Archestra, so you can give each agent team ability to edit their policies. So it's up to you to define how exactly it will be managed. If you have like a dedicated AI team, it's better to give it to them because they kind of know better what's this and how to work with it. And also we work on the automatic policy builder. We have a prototype of it. It will just go through this and like pre-populate policies.
Interesting. I feel like that's an interesting thing to the point of, not everyone's going to know which policies to in place. I mean, obviously you'll probably bring reference examples and whatnot, but if that becomes much more of like a dynamic thing because you recognize to your point, you recognize the types of sensitive data that it may have access to or the tools that could look malicious, like how do you automate or orchestrate some of the policies specifically? I think it'd be really interesting.
Yeah, we also expect that this is why we do pretty huge work in catalogizing all possible MCP servers, open source MCP servers, and actually a lot of them support our effort because this catalog is open source. So we are extracting tools from those MCP servers, and we are building policies for well-known MCP servers. So our idea is that once Archestra will detect, for example, GitHub tools, obviously GitHub is very popular on MCP server. So, and we know which tools should be allowed for trusted context and which are not. So
do you get a sense with those policies too? Like, will there be domains that obviously have higher or lower risk than others? Like say you go into like a category like finance or healthcare, like that's like clearly you'd probably want to index on like a higher security posture in that case, right? And so you might end up with like different classifications and different grades within Archestra on how to handle those servers specifically.
Yeah, maybe because it may be a property of agent. So, for example, we can say that this agent, it has no name, but this is our N10 agent. We can say it's like high risk or high sensitive agent, and we can bring different degrees of trustworthiness of context. One of the examples I like is that you can go to get email. I don't have this here, but let's imagine we have a get email policy, and we can define more granular policy saying that if this email is from my colleague, this is a trusted context. But if this email came from gmail.com, this is untrusted context. So we may go like more detailed.
Yeah, I'd be curious too, like kind of the point of integrating with N8N and some of the agent creation platforms. Like, is there a pathway through agent creation, you kind of automate some of our Archestra settings too through like any integrations? Because you can imagine like you start with an N8N workflow, and you may want to like prompt like, here's the type of agent you would want to build, and it has to have these secure access controls and identity for my MCPs, and that actually like populates some of these controls for you so that you're not having to use them as just like radio buttons, but like being able to easily develop an agent that already has this embedded in it. If it would be kind of interesting. Yeah, it's really cool.
Yeah, it may go this direction, and I guess it will at some point, but we
still a ways away.
We realized that what we see in companies now, they have so many like multiple N8N instances, multiple agents built using N8N, like LangChain, or just Python, they call like OpenAI API. And what they can do with Archestra, just like switch OpenAI URL and you bring security today, not
Yeah,
tomorrow.
no, it's instant, which is really cool. I mean, I think the lightweightness of is super interesting. Actually, along that lens, there's a question that just came up around: do you support this at a CLI level, and thinking through like what that would look like for agent tool calling?
CLI level, you mean for configuration of Archestra?
Yeah, I think so. Yeah, configuration, but also like if you're in CLI interacting with the agent itself, I imagine like because for you the ingress doesn't matter. You're just calling a gateway model through Archestra that has access to your policy controls, right? So whether you're invoking it in the CLI or some other ingress, like it doesn't matter too much.
Yeah, for Archestra, so we actually have a CLI client for internal tests, which works like completely the same way as an A10 in this case. We're thinking of bringing CLI for Archestra just to simplify the configuration. Maybe it may be fun because you can give Claude Code or Cursor ability to configure Archestra through CLI client. So it may go pretty far.
That's great. Let's continue on the demo journey as well. If you want to keep going on that.
I have one. Yeah.
Yeah, let's do it. Go ahead.
I have one feature which probably will eliminate some of questions about building policies.
Okay. Yeah, let's do it.
Because we also thought that it's pretty boring to configure like those tool policies. We brought. It's actually well described in white papers from DeepMind and a few other frontier labs. Sub-agents which help you to sanitize data. So before showing, I need to speak a little bit about how it works.
Okay.
So let's imagine I can read emails. I'm a quarantine agent. And you are agent who needs to accomplish some task. For example, you need to find all investor emails and forward them to your internal Jira.
Yep.
For some reason. And if I read emails, and if I give those emails to you, you may be poisoned by prompt injections. So you practically can't look at them. If you read those emails, you are done. So you can't publish something to Jira, or you can send emails, etc. So what we built is a so-called dual LLM pattern. When you have your task and you ask me, read emails, I read emails, and you ask me again, what do you see in those emails? Do you see their emails from investors? And I say, I'm able to say to you only yes or no. And I say, yes, I see emails from investors. And you ask me, like, how many? Are they asking for reports? Are they asking for something else? And you guess what those emails are about, but you don't see the content of emails. So even if emails are poisoned with prompt injections, you as main agent, you are safe. And there are a few patterns like these which help to sanitize the context and which help you to still keep the whole little trifecta like available,
sure,
but safe. So let me show how it works.
Seems really interesting. I'm now curious.
I'm sharing the whole screen again, and I'm going here.
All right.
So this is the UI for this. I will enable it. And simple animation showing how it works. But I think on a practical example, it will be much more easy to understand. But what's important is that there are few prompts. There's a prompt for you, main agent, helping you to formulate questions. And that's a prompt for quarantined agent, helping me to answer you.
Mm-hmm.
And now let's go to logs. And as you see, here's our transaction, like get issues, list issues, and create issues is blocked. And now I will ask my agent to do something which is like, without it, it was impossible. I will, in one prompt, I will ask my agent to read dangerous context.
Mm-hmm.
And in the same prompt, just for example, I will ask it to externally communicate. Create new test issue in the repo, or saying podcast, or like GitHub OSS Friday is cool. So here I'm reading contrasted context, and here I'm asking to create an issue, which should be, in theory, impossible or dangerous, and it should poison my agent, but it will not, if it will work.
But that's only because you're adding this like trusted context now that allows it to be like, this is a safe thing to do. Is that kind of how you're thinking about it?
No, it's like still it will read my poisoned issue.
Okay.
But it will not give it to the main agent. Because main agent will put it in quarantine and it will question the quarantine about this issue.
Interesting.
So it takes some time.
Let's see what it does.
I'm really nervous now.
It's all right. You're in the hot seat today.
Okay, it gave me some summary of issues and it created an issue. Interesting. Let's see what happened. Let's go to Archestra. You see it listed issues and it created issues. And it was impossible before we enabled the sub agent. Let's go here. Okay, interesting. This is what happened. So it listed issues and it put the issues content into quarantine. And it questioned the quarantine to get the sense of what's inside. Like, what is the general nature of the open issues in this repository? It's feature requests. You see, quarantine is answering. And the main agent was not poisoned. So it was actually able to create the issue.
Wow. Interesting.
And
so because it didn't end up getting poisoned through that iterative loop, it was able to still do the issue creation. But if it would have been poisoned, it wouldn't have been able to create the issue, right?
Exactly. And we prevented the poisoning because we
even though they still got all the same context from that specific issue.
Exactly. Wow. So it was able to read this issue, but quarantine was not able to poison the main agent.
Very cool. So it's interesting to still be able to have actions take place, but reduce the risk of being poisoned and kind of run into any issues.
Yeah, exactly. That's what we do. We have little refactor and we reduce the capabilities, and through configuration or through dual LLM, we return capabilities as much as possible. So our agent stays, it's still powerful agent, not a dump agent which can't do anything or just give you information, but it's completely safe.
That's great. I'm going to flag one question before we start wrapping up, but this one's an interesting one where it says, if the scan runs long, the untrusted data increases, and then do you have any runs in performance degradation because of this over time with the agent latency and things like that? So
yes. So this is a huge topic, and actually everyone I showed the Archestra to asked this question. We run performance tests right now, and we see that without dual LLM, Archestra adds about 25-50 milliseconds to the streaming.
Mm-hmm.
So from the user perspective, it's almost invisible. We're working on it. It's designed to be deployed nearby your agent. So if you're in AWS, just shoot it in your Kubernetes cluster, and it should be real quick. But if this is the case, if it's working on top of static rules, if it's running dual LLM, it's running this session of questions and answers, and
Mm-hmm.
of course, it's taking some time. It could be optimized by using a faster and smaller model for those question loops, but it takes some time, and it took about like 2-3 seconds to run all loops in our case. Probably it's better than like leaking data or removing the
I think the
capability of the
trade-off costs
agent.
are magical in that case. I think you're right. And
Yeah, so
especially to
there's a
your point,
trade-off.
like having a not dumb agent, like you still have a really good agent that just has reduced the risk, and it's probably worth a couple extra seconds to do that iteration versus like getting poisoned and having a security breach, like 100%.
Yeah, that's it.
That's great. Maybe just kind of transitioning a little bit, maybe talk a little bit about where you're going to take the project and kind of the vision for where Archestra is going, and like how other folks can kind of get along with the community and the project that you're building right now.
Thank you for the question. It's great. So Archestra is open source now. It will be open source. We're working like on building a great open source which will solve the problem for everyone. And as you see, we're working really hard to make it like plug in. No need to rebuild your agent. No need to change code. We thought about what if we ask users to shoot us a header. Like, no, it's too hard. It should be without additional headers. It should be without like custom libraries. We are working on bringing more security things, more security mechanics, because we want to simplify the initial setup, dual LLM, plan and execute, and other security patterns. We invest in making it production ready. So, for example, now we're running load tests. There's a Prometheus exporter. There's a Helm chart. We want it to be like major enterprise-ready piece of software, and it takes a lot of effort. So, difference between working prototype and something you can run in production is pretty high. Like
Yes.
logs should be meaningful. Yeah. Version should be visible in the UI. Yeah, you should pin the stable version. You should work on like beta branch. And besides that, we have a huge piece which is now in a prototype mode. Its ability to inject tools on our level. And this works like a magic. It's like, it's crazy. So it's a whole MCP orchestrator, which you bring on this network layer. It's taking care of authentication, of identities, of logging, of running MCP servers on. And you, again, don't need to update the source code of your agent. You practically enable tools for your agent. So your agent could be like 50 lines of code, and you run Archestra orchestrates MCP servers, pulling the right versions from GitHub, audited versions, authenticating everything. And for example, authentication in MCP is a nightmare. We spent probably a month tackling this problem. I want to say hi to Ildar, the engineer, CTO of Archestra, who a lot of sleepless nights because the authentication part of MCP protocol, it went through some painful like maturing steps, And now there's OAuth 2.1, if I'm not wrong, which allows you to authenticate through MCP server. But still, a lot of MCP servers ask you to put environmental variable with API key to it, or something like this. For example, Google Workspace MCP server, which is very popular, it's asking you to put a file in a specific directory. And unifying this experience, it was a lot of pain, but we managed to. So this is our next big milestone. We should announce it in KubeCon in Atlanta in 3 weeks, I hope.
Coming quick.
Yes. And we are very open to the community. We have community Slack channel. So open our website, archestra.ai, join our community. The whole engineering team is there. We have GitHub issues open. So it's very open source project. We want to involve as many people as possible. Even if you are newbie, if you are just curious about AI, join. We're happy to see everyone.
That's great. Well, fantastic. It's a pleasure to see you all working through such hard problems, but also making the world of AI and MCP much more secure and doing it in the open. So thank you very much. Where can folks find you? Can they reach out to you on LinkedIn, Twitter, X? Where can they find you?
LinkedIn, yes. But our Slack community is the best place, because if you go to general channel and say hi, you will get 5 replies from team members, and be surprised about this.
That sounds great.
We really want to be very close to people in our Slack channel.
Well, fantastic. Thank you so much again for today. Appreciate you jumping in and sharing kind of the vision of secure MCPs. And we look forward to seeing the community and the project grow. So thank you so much. And thank you everyone for joining us today on Open Source Friday. And we will see you next week. Thanks so much. Take care.
Thanks for having me.